you make y as the subject?
Y equals to 6.
Why is y equals to 6?
Oh, y equals to 12 over x.
Very nice. Okay, now what is your technique here? Do you want to use quotient rule or do you want to use some other technique?
Bring up.
Very good. Good job. Okay, please differentiate for me.
Negative 12x to the power of negative 2.
Okay. So to find the gradient value, what will you do?
Put in the 2.
Nice. Okay, Jensen, can we go to the next question now? Number 9. Can you please read for the class?
Find the gradient of the curve y equals 5x squared minus 8x plus 3 at the point where the curve crosses the y-axis.
Okay, can you state all the keywords that you just read?
Find the gradient.
Okay, how do you write gradient in notation?
dy dx.
Okay, can you tell me the dy dx now?
10x minus 8.
Okay, one more keyword.
Curve crosses the y-axis.
What happens at y-axis?
The y is 0.
Crossing the y-axis and the y is 0. Are you right?
The x is 0.
So tell me the value of your gradient now.
Negative 8.
Yes, that's simple. Good job, boy. Now, can I have Nesha to read 15?
The curve y equals ax plus b over x squared has gradient 16, 1 x equals to 1, and gradient minus 8, 1 x equals to minus 1. Find the value of a and the value of b.
Okay, so you see the word gradient. What do you want to do with the y, Nesha? Same process like what Jensen did just now. When he saw the word gradient, what process did he do?
You differentiate first.
Very good. And what is your technique in differentiating? For this particular part here, do you want to use quotient rule or you want to bring up? My b is a constant, right?
All right.
So we can bring it up. Okay, help me to differentiate now.
A
Very nice.
plus negative 2 bx minus 3.
I'm just rearranging so that it becomes easy for you. Okay. After this, what should I do, Nesha? Look at these two information given here. They say the gradient is 16 when x is 1. See? You have a gradient expression now. What can we do?
You put it in.
Yes, correct. Okay, let's ask Jason for his answer. Jason, I have two unknown and I have two equation already. You want to substitute or you want to eliminate, boy?
eliminate.
Yes. Should I minus or should I add?
Add.
I'm doing from bottom to up, so I minus, yeah? If you want to add, you can. Richie, share your A value when the B is -6.
Wait. You minus, miss? Why is it for B?
Because I went and minus.
Oh,
I took the bottom and I minus the upper one.
is it 4?
Yes, correct. A, you will get plus 12, 16, right? So it's 4. Nice. Any doubts so far? I think you are good in this. Your technique of differentiating is good. Are we learning anything new? No. All this is IGCSE still. Gabby, can you read question 18 for us, Gabby?
Given that y is equals to 4x cubed plus 3x squared minus 6x minus 9, find the range of values of x which dy over dx is bigger equals to 0.
Okay. Girl, what is the meaning of dy dx bigger or equal to 0? The gradient is being?
More than 0.
Anybody wants to help her? What is the nature of the gradient now? Is it positive or negative, Warren?
Positive.
Yeah. Okay, go back to Gabby again. Gabby, you see the word dy dx. So what do you want to do with the y?
Differentiate.
Help me.
12
Yeah,
x squared
nice.
plus 6x minus 6.
Okay. So I am taking more or equal to 0 and I'm putting it here. Now, I want Russell to help me. Russell, what is the meaning of range of values of x? What is this, boy?
So it's going to be an inequality.
Very good. The answer is going to be in an interval form. You cannot go and write an equal answer. Set of values of x, range of values of x. Answer has to be in the form of an interval. It can be an interval or more than, less than, inequality answer. Okay? Okay, let's solve then. Russell, help. 12, 6 and -6. What do you want to do?
Factorize.
Yes. Before factorizing, can I just divide everything by 6?
Yes. Become x squared plus x minus 1. 6.
Factorize.
2x squared. So x plus 2, 2x plus 1 and x minus 1.
2x plus 1 or 2x minus 1?
I mean 2x minus 1 is 2x minus 1 and x plus 1.
What chapter is this? Can somebody recall? Chapter 1 of term 1, quadratic inequality. What is the method? Find the critical value. You draw the number line. You can draw the graph itself or you can choose to do number line, yeah? Then you find the solution. Okay, let's ask Sri Raharju. Sri, what is your critical value, boy?
What, miss?
What are your critical values in that inequality, quadratic inequality?
X bigger than half, X smaller than -1.
Okay, he is directly telling the answer, yeah? He's directly telling the answer, that's fine. More or equal to 0 means lies above x-axis. So you can just do -1.5 here. It's still a positive curve. And according to Sri Raharjo, we want it to be above the x-axis. Any doubt so far? If you don't like the sketching method, how else can I solve? I think in Sec 3 you learn cubic inequality, right? Your teacher must have taught you number line technique. If this is difficult for you to interpret, then you do the number line technique. It's much easier. You put a -1 here, you put a half, you put a dotted line. Those who don't know, you see here. And then you pick some nice integer values. I'm going to pick 1 and I'm going to pick 0. I'm going to pick -2. You take these values, you put into the dy dx that you just got. Take and put, analyze, inspect the value. If I put 0, what will I get? Sajida, you want to help me? If I put 0 into that, what do I get, girl?
-1.
Very good. Try putting 1, what do you get?
Mine 0.
Are you sure? 2 minus 1 is 1. And then 1 plus 1 is 2. 1 times 2 is what? You get a -5 here. I'm just putting into the factor. Then you get 5 here. More than equal to 0 means positive. So which part is it positive? Here and here. So your answer is going to be this one. More equals to half, less or equal to -1. You can use the number line technique as well. Any questions so far? Okay, Nabil, you read question number 19 now, Nabil.
A curve has equation y equals 3x cubed plus 6x squared plus 4x minus 5. Gradient of the curve is never negative.
Okay, the question says gradient is never negative. Gradient is never negative. Ladisha, interpret the meaning of gradient is never negative. How do I write this in mathematical notation?
Bigger and less than bigger and equals to 0.
Okay, more equals to 0 and the gradient is just dy dx. Is 0 a positive number? 0 is not a positive number, yeah. 0 is a scale which defines positive number and negative number. So when they say gradient is never negative, you know gradient is positive. I mean, typically you can write more than 0 or more equal to 0. They won't penalize you for now. Okay. So now how do I do? First step is definitely finding the dy dx. I'm very sure most of you already did this. Okay, let's ask Hanson. Hanson, how to do this now? How do I show it's never negative, boy? This is also quadratic chapter, chapter 1, term 1. So, a quadratic function. There are 3 methods. Can you please tell? Any one? Okay, never mind. Good try. Let's ask Brian. Brian, name any one technique. How do you show a quadratic function is always positive?
I don't know.
Okay, anyone from the class? Just tell me one method, then I will help you with the others. William.
I'm not sure, miss.
Varun.
X is square.
What do you mean by square, boy? You're almost there. What square?
Yeah,
Something
squared.
completing of square. You can complete the square and try to check. Okay. Or you can use graphical method. You can sketch the quadratic function. Or what is the last one? This is students' favorite technique because it's very fast. Anyone knows? Just now in the JC1 Forbes, the other William answered. It starts with D.
Discriminate.
I knew Richie will answer. Discriminant method. What discriminant should I use, boy? Which one? B squared minus 4ac. Which one to show it's always positive? Less than 0, more than 0, or equal to 0?
More than?
Let's check. 2 intersection point, 1 intersection point, more. Can you tell the discriminant concept, Richie? For the first one?
If it's more than 0, there's 2 intersection points.
Yeah, then how? You want to be positive. So positive means cannot lie below the x-axis. So will you go for more than 0, equal to 0, or less than 0?
Equal.
Equal or less than 0. You can merge this part. Okay. So you try. I am going to do completing of square because I'm lazy. I saw a pattern. I saw a 9. I saw a 4 here. And I can quickly write it as 3x plus 2 squared. You do do the checking. Check by expansion. I get 9x squared, 12x plus 4. I know I'm right. Then I go with what Warren said. When I square, then how to write? For any x value, for x element of real number, I know the dy dx is definitely more equal to 0. So this is method 1. If you don't like method 1, you go and do your method 2. I'm going to do discriminant. It's also much easier. Um, 36 times by 4, 144, 0. Means only one point of intersection. And you know it is a happy parabola. So definitely lying above the x-axis. So how do you write? Since b squared minus 4ac equal to 0, then dy dx is never negative. Or you can just write it in inequality format, whichever way you like. Any questions so far? If you are done, go to page 201. You try 6 and 8. Isabel, can you read for the class? Or am I too fast, girl?
Find the gradient of the curve y equals to x minus 3 over x plus 2 at the points where the curve crosses the x-axis.
Okay, what does it mean when you say crosses the x-axis?
Y equals to 0.
Very good. You do that later, but I'm interested with the gradient now. Okay, now tell me the method to find the gradient. You want to use quotient rule or you want to bring up?
Bring up.
Okay. Please tell your dy dx. What's your dy dx, Isabel?
Wait, miss.
Miss, what page is the question?
201. If I differentiate 1, what do I get, Isabel? I mean, differentiate x. Oh God, I told you the answer.
1.
Yeah. And then the other one? Power down, power minus, differentiate the inner part.
Plus 3x.
Okay, if I differentiate the inner part, I'm just getting a 1, so no need to write anything. So far, everything is good. I'm just going to rearrange. Okay. So looks like I'm going to get 2 different gradient now because we have 2 different x values. Based on what Isabel read, she said the function crosses the x-axis. So there are 2 x-intercept now. So looks like at x equal to -3, the gradient is steeper compared to x equals to 1. How many of you can imagine what's happening here? I mean, you are algebraically doing this. Can your brain digest the geometrical part of this? Let me try to show you what is exactly happening. Russell, can you read the function for me? X minus 3 over what, boy?
X minus 3 over x plus 2.
X plus 2. So let's look at the graph now and see. We got this and the graph is actually crossing at the y, at the x axis. We are getting 1 and negative 3. So when we are getting 1 and negative 3, look at the slope. You go and draw a tangent line. You draw a tangent line. I think I will just use this cursor. If I draw a tangent line here, see, it's going to be a straight line over here. It's much steeper than when I put it on the 1. This is what's actually happening graphically. Okay, now Annabelle, you will end the working class work today by reading question 8.
The curve y is equal to a over bx minus 1 passes through the point 2, 1 and has gradient negative 3 over 5 at this point. Find the value of a and find the value of b.
So there are two questions given. They say the curve passes through 2, 1. It means the 2 and 1 belongs to the curve. I can input. And then they're telling it also has a gradient of negative 3 over 5 at x is 2. What is your thought process, Serafina? Serafina? Okay, let's ask Ivy. What's your thought process, Ivy?
Input the coordinates first.
Okay. Input. And then next thought process?
Differentiate.
Very nice. How to differentiate, girl? What technique? Am I using quotient rule or can I just bring up? Think the A's. Yeah. Because okay, do the dy dx for me, Annabelle. And then my Jason, he haven't answered for the day. Power down, power minus, differentiate inside. Do it, Jason.
Minus a bracket bx minus 1 minus 2b.
Very good. Good job. I'm just making it to look better. And then I know the dy dx is negative 3 over 5 when x is 2. Okay, let's substitute. Okay, I think I don't want to substitute. You know why? Because I saw something over here. The 2b minus 1. And here when I substitute, it's exactly the same. I just replace with a. Replace. Two into 1. Brian, check your B answer with mine. What is your B?
3.
Good job. Okay. Did we learn anything new? No. You already know very well on the technique of differentiation. You just finding gradient.